Okay, let's take a look at this problem. So the strategy you need to use for all projectile motion problems is that you have to list your information in the x and y direction completely separate from each other. The only thing that is the same is the time, because, well, let's look at this situation first. We have a hawk that's flying horizontally, okay, that's holding rubber chicken. So that means the rubber chicken is moving with the same velocity as the hawk. As soon as the hawk releases it, the rubber chicken begins to accelerate due to gravity. Nothing has interacted with it in the x direction to cause it to speed up or slow down. So it maintains that horizontal velocity the entire time it falls, okay? But it begins to curve down under the influence of gravity. So since the velocity is 13 meters per second, when it's released, it maintains that same velocity the entire time, okay? It's the vertical component that changes. Now, if this is what's happening, the time that it takes for the object to stop moving horizontally is the same time that it takes for the object to stop moving vertically. All right? So that time for both the x direction and the y direction are equal to each other. If we start to list our information for this problem, okay, it tells us that the initial horizontal velocity is 13, so that means as soon as it's let go, it's going to maintain that 13 meters per second. It wants us to find the horizontal x. So if I look in my x direction, x is equal to velocity times time. Well, in order to get x, I need to figure out time. Since it's not given to me in the problem, I have to be able to find it from other information. If it's not in my x direction, I'm going to have to look at my y direction. So let's look at what we know in our y direction. So my initial y velocity, so as the hawk is flying horizontally, it is not moving up and down. So the initial y velocity is 0. The object is going to accelerate due to gravity. I need to find the time in the y direction. It means I need to know one more thing. I either know the final velocity or I know the delta y, the change in height. Okay? If I look at the problem, it tells me that it was dropped from a height of 100 meters. So if I make the ground 0 meters and the point at which it was released 100 meters, okay, the delta y, the final, ended here, minus the initial, is going to be a negative 100 meters. So that is the only variable that I do not need to find the time. From the given information, this is the equation that's going to work out best because I don't know the final velocity. This contains everything else. Because the initial velocity is 0, we can manipulate this down so that the time is equal to 2 times delta y over the acceleration square rooted. Okay? So notice that we have this negative here and this negative here. Those are both very important. When we plug it into our calculator, we can do the square root of 2 times negative 100 divided by negative 9.8. Now, if you don't have both those negatives, they can't cancel each other out, and you can't take the square root of it. So make sure you have your negatives. And we get a time of 4.5 seconds. So now that we found the time, it belongs in the x-axis as well. So we only have one unknown there, so in our equation we can do 13 meters per second times our 4.5 seconds, and we'll get an answer of 58.5 meters of distance that is covered in the x direction. Okay, so from the point that it was released, it's going to travel a distance of 58.5 meters.